Simplify the expression. Write your answer as a power. 4 to the 5th divided by 4 squared. In this problem, we are dividing powers with the same base, 4. To divide powers with the same base, you can use the quotient of powers property. The quotient of powers property states that to divide powers with the same base, subtract their exponents. In the example given, to find 3 to the 8th divided by 3 to the 6th, you write the base 3 and then subtract the exponents, which are 8 and 6. Because 8 minus 6 is 2, 3 to the 8th divided by 3 to the 6th is equal to 3 squared. And in the algebra example, a to the m divided by a to the n is equal to a to the m minus n, where the base a is not equal to 0. This condition is in there because if a were 0, then you would have a to an exponent in the denominator, which would be equal to 0, and division by 0 is undefined, so a cannot be 0. Now we can find 4 to the 5th divided by 4 squared. 4 to the 5th divided by 4 squared is equal to 4 to the 5 minus 2, because we subtract the exponents. 5 minus 2 is equal to 3, so you have 4 cubed. So 4 to the 5th divided by 4 squared is equal to 4 cubed. Let's try another example. Negative 2 to the 10th divided by negative 2 cubed. Use the quotient of powers property to solve this problem. You can write the quotient as negative 2 to the 10 minus 3, because we subtract the exponents. 10 minus 3 is equal to 7, so we have negative 2 to the 7th. So, negative 2 to the 10th divided by negative 2 cubed is equal to negative 2 to the 7th. Let's try another example. P to the 7th divided by p to the 6th. You can also use the quotient of powers property to solve this problem. You can write the quotient as p to the 7 minus 6, because we subtract the exponents. 7 minus 6 is equal to 1, so we have p to the 1st, which can be written as just p. So, p to the 7th divided by p to the 6th is equal to p. Simplify 5 to the 6th times 5 squared, all divided by 5 to the 4th. Write your answer as a power. First, let's write the expression. 5 to the 6th times 5 squared, all divided by 5 to the 4th. Notice that all of the powers have the same base, 5. You can use the product of powers property to simplify the numerator. The product of powers property states that to multiply powers with the same base, add their exponents. So, you can write the numerator as 5 to the 6 plus 2. And then the denominator is still 5 to the 4th. 6 plus 2 is 8, so you have 5 to the 8th divided by 5 to the 4th. Now you are dividing two powers with the same base. You can use the quotient of powers property. The quotient of powers property states that to divide powers with the same base, subtract their exponents. 5 to the 8th divided by 5 to the 4th is equal to 5 to the 8 minus 4, which is equal to 5 to the 4th. So, 5 to the 6th times 5 squared, all divided by 5 to the 4th, is equal to 5 to the 4th. Simplify x to the 6th divided by x squared times the quantity of x to the 8th divided by x to the 5th. Write your answer as a power. In this problem, you are multiplying two quotients. Notice that in each quotient, the powers have the same base, x. So, you can use the quotient of powers property to simplify each quotient. The quotient of powers property states that to divide powers with the same base, subtract their exponents. So, let's write the expression first. X to the 6th divided by x squared times x to the 8th divided by x to the 5th. Using the quotient of powers property, the first quotient can be written as x to the 6 minus 2, and the second quotient can be written as x to the 8 minus 5. 6 minus 2 is 4, so you have x to the 4th. 8 minus 5 is 3, so you have x cubed. So you have x to the 4th times x cubed. Now you are left with two powers with the same base to multiply. You can use the product of powers property. The product of powers property states that to multiply powers with the same base, add their exponents. So, x to the 4th times x cubed can be written as x to the 4 plus 3. 4 plus 3 is 7, so you have x to the 7th. So, x to the 6th divided by x squared times x to the 8th divided by x to the 5th is equal to x to the 7th. The projected population of Hawaii in 2020 is about 5 48/100 times 2 to the 18th. The land area of Hawaii is about 2 to the 14th square kilometers. Predict the average number of people per square kilometer in 2020. We can use a model to find the average number of people per square kilometer in 2020. The people per square kilometer is equal to the population in 2020 divided by the land area. Let's look back at the word problem to find the information we need for this model. The word problem says that the projected population of Hawaii in 2020 is about 5 48/100 times 2 to the 18th. This matches the population in 2020. The word problem also says that the land area of Hawaii is about 2 to the 14th square kilometers. This matches the land area. Substitute these values into the equation. So we have 5 48/100 times 2 to the 18th divided by 2 to the 14th. Using the definition for multiplying fractions, we can rewrite the quotient as 5 48/100 times the quotient of 2 to the 18th divided by 2 to the 14th. Notice that now you are dividing two powers with the same base, so you can use the quotient of powers property. The quotient of powers property states that to divide powers with the same base, subtract their exponents. So we have 5 48/100 times 2 to the 18 minus 14 because we subtract the exponents. This is equal to 5 48/100 times 18 minus 14 is equal to 4, so we have 2 to the 4th. 2 to the 4th is equal to 16, and the product of 5 48/100 and 16 is 87 68/100. The problem asked us to predict the average number of people per square kilometer in 2020. So in 2020, there will be about 88 people per square kilometer in Hawaii.